Let's discuss when to use Wireshark. Let's begin with a discussion on the different types of users that may want to take advantage of the Wireshark features. The first is your IT professional. In my opinion, because of the importance of networking in today's IT arena, I think every IT professional should have a rudimentary understanding of Wireshark and be able to look at packet captures. But without doubt, the dominant user of Wireshark is your network administrators, your network engineers, those people that are responsible for keeping the network up and running and performing well. My son is in this role, and a few weeks ago he called me and told me, we're having such terrible performance problems at our company. And I said, have you run Wireshark and looked what's happening? And he connected it at the appropriate part in the network, and he was able to see that the TCP window size was dropping down to 0, which indicates quite a significant problem. He was then able to troubleshoot that and then have the discussion with the ISP, and because it turned out to be a problem with the ISP equipment. Developers can also benefit from Wireshark, particularly if they're working down at a level that they need to debug messages that are going across the network or debug protocols themselves. And they can see when messages are going across and maybe messages are failing to go across the network. Application developers can also benefit from Wireshark because quite often the performance problem is not the network, and it can actually be at the endpoints and sometimes triggered by the way the application is interfacing with the network protocol stack. And my last use case, but not the last type of user that would want to use Wireshark, is my network security engineer. Now, you need to be clear that Wireshark does not replace an intrusion prevention system, because intrusion prevention systems monitor the network all of the time. In Wireshark, you typically create a capture when you need it, and quite often if there's been a breach on the network, the time you bring up Wireshark, the breach has already occurred. But it can be really useful for testing your theory on what caused the breach, simulating it and looking at how that network traffic went across the network. So I see a lot of security professionals really using Wireshark to help them troubleshoot network breaches. So what kind of things can we do when it comes to analyzing network traffic? One of the things we can do is to detect errors. For example, what if I've got a lot of retransmissions of my IP packets triggered at the TCP layer? Then that might indicate that there's a problem somewhere in the network that I need to investigate. Troubleshooting performance problems. If a user says the network is slow today, then I can look at the traffic going to and from that user device, and I can see, maybe there's a performance problem when they connect to a particular server, or maybe there's a performance problem regardless of what activity they're doing. So I can start troubleshooting that network performance problem. It's not unusual for a piece of networking equipment to go bad, and you can start to see a huge number of errors into the network. Well, Wireshark will show you those errors, and by taking your capture at various points in the network, you can start to say, this is the node that's causing the problem. Reconstructing events. How many times have you had a problem and it's been intermittent? Those are perhaps the worst ones to troubleshoot. Wireshark will let you start a capture, and then when the problem occurs, the user or someone can call you and say the problem just occurred, and then you can stop the capture and take a look at what happened when that occurred. And simply by looking at the Wireshark packet capture, you can become familiar with the traffic that's going over your network. And if you're going to manage a network, you really need to know what traffic normally goes over that network. And the last one is policy infractions. Most organizations have a network usage policy. For example, whether or not you can use the network to access your personal email or to surf the web and go to certain sites. When you capture network traffic, you can analyze it to see if there's been any policy infractions that need to be addressed. Wireshark not only displays the packets for you to look at, but also provides statistical reports. This particular report is looking at the packets that are being sent over time. This can be useful if you're doing packet analysis, so you can start to see what your throughput is over a network and what the fluctuations are during the day. It's also relevant to do protocol analysis. So for instance, the black line could be my overall number of packets that are going across the network, and the red line could be my UDP packets. So you can start to understand the different types of packets that are going over your network. And lastly, I have network analysis. You can see in this picture that there are times where transmission drops to near zero and I'm not sending anything across the network. Now, that could be there's no traffic, but it's much more probable that when it drops to zero like that, something is happening that's preventing traffic going across the network. So that warrants further investigation. So Wireshark can be used for a variety of purposes in analyzing your packets down at the protocol level or looking broadly at your network. What protocols does Wireshark look at? Well, Wireshark has hundreds of protocols, all the basic common ones that you would expect, starting at things like HTTP, coming down to TCP and UDP protocol, of course IP, your Internet Protocol, of course both version 4 and version 6 are supported. Coming further down at the data link layer, you may want to look at Ethernet or even your Wi-Fi networks. Looking at DHCP and DNS can really help with user connectivity problems. You can even look at routing protocols like RIP and Border Gateway Protocol. These are the protocols that transfer information between routers regarding updating routing tables. ICMP messages, which you can use to look at network errors that are being reported on the network. And protocols like IPsec, IPsec, that are looking at things like EAP, PEEP, TLS, SSL. Those protocols can all be looked at in Wireshark. And the list goes on. Each protocol that's supported in Wireshark has its own dissector. And if there's a protocol that's not supported by Wireshark, you can actually develop your own dissector to look at that protocol and maybe even contribute it towards the Wireshark repository so it makes it available to everybody. So the number of protocols that are supported is significant and it is growing. Baselining is incredibly important if you're going to look at network performance issues. So when you look at network performance problems, how do you know you have a performance problem? The way you know is you say this isn't normal. So you can use Wireshark to capture traffic under normal conditions and do the measurements and say this is what normal traffic looks like. So then if someone is saying there's a performance problem, you can actually compare it, what the traffic looks like today with what it would look like in normal conditions. And you cannot troubleshoot a performance problem without knowing what your normal baseline traffic is. So Wireshark is a really good tool for capturing traffic under normal conditions and creating baseline measurements.